Hi students, here I am Nitesh Ranjan in front of you. I am the faculty of physics and today the topic which I am going to cover is of circular motion. Even though we all know that circular motion doesn't hold any specific marks in examinations of JEE, but it holds an equal importance in each and every chapter which we go through in the subject of physics. So I will let you know about each and every point which circular motion holds, and then I will let you go through each and every type of numericals. For all this to happen, I am going to take the series of this circular motion in whole 6 classes consecutively after today's session. Now, what will be there in today's session? We are going to start the class now, and then we will be knowing that which are the topics which I am going to cover, and if there will be any doubt, then you can just ask it to me in the chat box, and you can just ask the questions to me now. Fine. So we are now going to start the session, and I know you all are going to get a very entertainment session today. So be energetic, hold your pen, and then take out your notebook and write down each and every point which you think it is very important for you all. Now we are going to start the session. Let us start this with a smiling face. Okay. So here it is circular motion. Fine. Today we are asking you about what is the importance of circular motion in physics. So for all this to know, we are going to start with this session. First of all, what this circular motion is and how it is different from rotational motion. Fine. So we all know about rotational motion and circular motion. So in circular motion, what happens? We consider the object to be a point object. We consider the object to be a point object. Similarly, in a different form, if I am going to talk you about rotational motion, so it is going to be the condition of rigid body, and it is not the point object, right? It will be having some dimension. I mean, it will be having some length, breadth, and height. So that way, I can say you that the object will have some dimension. Now you will be thinking that if it is having some dimension and if it is considered to be point object, then what are the basic differences? So basically I have been differentiated it here, and when we will be starting with the rotational motion, I will make it very clear to all of you that what is the more deep differences between these two topics. Now if it is the point object, so definitely I am not going to talk you about the dimensional part. So that is the main part in circular motion. So we are going to start with the circular motion part, right? So here two of the conditions are there. One is uniform circular motion in abbreviated form. We can write it down UCM. It is uniform circular motion. Wow, great. It seems to be a very standard nomenclature. So now we are going to talk about the another part, another segment of the circular motion. It is non-uniform circular motion. So if it is non-uniform circular motion and if it is uniform circular motion, what are the differences here? So if it is uniform circular motion, what does it mean? It means alpha will be equals to 0, right? And if it is alpha is equals to 0, it means tangential acceleration will be 0, and there will be one acceleration which will be known as radial acceleration or will be known as centripetal acceleration, which will be present in this condition. Now if I am talking to you about uniform circular motion, what it is, I will make it clear in the next slide. Now coming to the point, non-uniform circular motion. If it is non-uniform circular motion, what does it mean? It means that alpha is not equals to 0, and if it is not equals to 0, there will be some differences from omega naught to omega. What is omega? So this omega is known as angular velocity. It is known as angular velocity. Very nice, students. I think each and every point of this slide is very clear to all of you. Now, considering that you all have understood all these points, I am now taking you to the next slide. And next slide, I am now talking you to about non-uniform circular motion part. So here it is, non-uniform circular motion. Great. Now, if it is non-uniform circular motion, what does it mean? So if it is changing from omega naught to omega, mind it, students, we all know about rectilinear motion, right? We all know about rectilinear motion, and it was very easy. In fact, you all know about all this. And what was the condition of non-uniform accelerated motion? That way I will be asking to you in the latter part of the session. Right now I am asking you about the condition in which it is uniformly accelerated motion, and then I will be asking to you about non-uniformly accelerated motion. So definitely here I am talking to you about two conditions. One is uniformly accelerated, and another one is non-uniformly accelerated. Now there will be one question in your mind, that what is the difference between uniformly accelerated motion and what is non-uniformly accelerated motion. So I will make it clear to all of you. As because I am talking to you about uniformly accelerated motion, it means what? Alpha is going to be constant. Alpha will be constant, and if it is alpha is equals to constant, it means I can apply the equation of kinematics, which we have been knowing about all the equations in rectilinear motion. The analog of all those equations here in circular motion, I will be applying it here. So that way, if it is alpha is equals to constant, it means what? Omega naught is changing from omega naught to omega, or there may be the condition that object is starting from rest, and there will be one condition of theta. So theta is angular displacement. So don't panic, these all are the terms which are very familiar to all of you. In the next slide I will make it very clear to you all. Here just I am considering that you all are knowing about all this nomenclature, and that way I am just dealing with the topics. Now coming to the point, non-uniformly accelerated motion. So if it is non-uniformly accelerated motion, it means I am going to apply the mathematics of calculus, differentiation and integration, as similar to what we used to do in rectilinear motion. Fine. So here two cases are there. We all are seeing it in this particular slide. One is uniformly accelerated, another one is non-uniformly accelerated. As because we are talking about alpha, omega and all, we must know that what is alpha, what is omega and what is theta. Sorry. So if it is rectilinear motion, so we all are knowing about the equations. What are those equations? V is equals to u plus at, then v square is equals to u square plus 2as, then s is equals to ut plus half at square, and then s nth is equals to u plus a by 2 into 2n minus 1. That these are all the equations which we know already in rectilinear motion. Fine. So I think all of you will be facing a very familiar names here from this rectilinear motion condition. So that way, I think that you are very happy to know about the condition that if you are very expert in rectilinear motion and these equations, then believe me friends, the next slide which I am going to cover are all going to be very easy to all of you. So let us move to the next slide, and now we will be talking about uniformly accelerated motion. Before that, I will make each and every nomenclature which I have used very clear to all of you. Now friends, I am now talking about nomenclature part. Fine. So here I am first of all talking to you about angular displacement. Great. Angular displacement is what? So basically it will be represented by theta. And now what is theta? If you will be asking to you about what is theta, I will tell you that if suppose I am having some circular path, if I am having some circular path and this is the center, from here some radius if I am taking. So if this point I am talking to you and at this point some ant is there or you yourself is sitting over here and you are moving like this as similar to merry-go-round. So I am making it more bigger in diagram so that it will be very clear to all of you. Great. Fortunately, this diagram has become very clear. Great. Now this is the radius r. This is something tangent to this particular radius. Great. Now coming to the point here. If suppose some object was initially at this point, so this one will be considered as r initial, as because initial position it is representing. Now if this same object has come to this particular point, now at this point I am again going to draw one tangent. Now students, this will be considered as final position. So this one was initial position, this one is the final position. That way, if I am talking to you that what I need to do, then by the help of vector algebra or vector which you have studied in basic mathematics, we can just form one diagram of initial position, final position, and then we can find out the displacement. But that will all be done in rectilinear motion condition. Now I am telling you in the angular format. Suppose here it has been moved from this point to this point, so this one will be considered as theta, and this theta will be having the SI unit of how much? SI unit will be radian. Now friends, one question will be there in your mind that we all are knowing about the degree form of angles, but if it is radian, how we need to represent it? So that for that I am now going to make it more clear. I am now going to elaborate it. How? So you all know that 2 pi radian will be equals to 360 degree. Fine. So 1 radian will be equals to how much? 360 by 2 pi. Great. So that way it becomes how much? 180 degree by pi. Wow. So this is like 1 radian is equals to 180 degree by pi. So that way, if I am now talking to you about degree, then 1 degree will be how much? Pi by 180 radian. Great. How? By cross multiplication. So that way, if it has been done, see, these are the mathematics which you not need to just prove it, or you don't need to just write down in your notebook. These are all for your knowledge. If you will be knowing about this condition, that how 1 degree is pi by 180, so you will never forget the basic condition, that how to convert the degree into radian. For that purpose, I am making it clear to all of you. Friends, now coming to few of the examples. As because each theory must be backed up with some example, I am now talking to you about 45-degree, friends. So if I am talking to you about 45-degree, how I am going to convert it in radian? So if 1 degree is pi by 180, so that way 45-degree will be how much? So 45-degree will be equals to 45 into pi by 180. Great. Radian. So if it is 45, so by how much times it will cancel this particular 180-degree value? 5 9 ja 45. 5 3 ja 15. So 9 4 times it will be 36. So pi by 4 radian it will be. So I know all of you are knowing about 45-degree to be known as pi by 4 radian, but how we all consider 45-degree as pi by 4 radian, that I have made it clear to you. So that way, if I am taking the next slide and I am making more clear in the examples, we can write down what? If I will be telling you about 60-degree, how much it will be in radian? Pi by 3. Great. Now if I am talking to you about 90-degree, how much it will be? Pi by 2 radian. Great. How? So refer to the previous slide. Great. So all these slide I am going to just make the link, and I will just paste it in the description. You can go to the description and then just download it. It is so easy for you all to know about all these conditions. So that way, theta is very clear to you now. Theta is now very clear to all of you. Now let us make more clear condition with omega. What is omega? Omega is known as angular velocity, as similar to the velocity. We all knew in velocity condition that if there will be acceleration, then only there will be the condition of velocity, and if there will be some velocity, then only we can displace from one point to the another point. Great. So that way, if I am talking to you about omega part, so friends, if we are having theta value, so omega is known as nothing but the rate of change of displacement with respect to time is known as omega, and the SI unit of omega is nothing but radian per second. It is so easy. Friends, here you are seeing it. And one more thing, I must make it very clear to you. So here I was using omega, and before that also I used some condition like alpha, omega and all. So sorry. So for all that to understand, I must know that what is the SI unit of omega, what is the SI unit of theta and all. So that way omega is now clear to you all. Omega is d theta by dt, and its SI unit is radian per second. What was the SI unit of angular displacement? It was the radian. Now comes alpha. Alpha is nothing but the rate of change of angular velocity with respect to time. Also it is known as omega d omega by d theta. So this is the mathematical relation of alpha. Now you will be asking to you how I have made it like omega d omega by d theta. So all this you will come to know once you will be knowing about function of function in mathematics. So that way you will come to know about these two equations. Now as because these two equations exist, I will be now taking you to the next particular part. Before that, I must recap all the points which we have covered till now. We have come to know theta is what? Theta is uh, theta is angular displacement in fact, and angular displacement means what? Theta final minus theta initial. Its SI unit is what? Its SI unit is what? Its SI unit is radian. Great friends. Omega is what? Omega is angular velocity, and what it is? D theta by dt. Its SI unit is radian per second. Now comes alpha. Alpha is what? D omega by dt, or omega d omega by d theta. Its SI unit is what? Radian per second square. It is so easy. Now friends, one thing I have to make it clear to you. As you came to know about this diagram here, one thing I have to make it clear is what? That always and always the velocity will be perpendicular to the radius. Why? Because once it will be acting perpendicular to the radius, it will be changing the position of particle from one point to the another point. Great. So that way we have come to know about this velocity part, and this velocity is changing. I mean what? I mean what? If I am telling you that a is equals to dv by dt, then we must know that a is the vector I mean quantity. So if it is vector quantity, so definitely velocity will also be vector. And vector means what? It is having magnitude as well as direction. So definitely in this formula it is telling you that velocity, I mean the velocity will be having its magnitude as well as direction, and both are changing with respect to time. Yes, so that way it is very easy to you to understand that if a is equals to dv by dt, and if velocity is changing, so there will be one condition in which direction as well as magnitude both will be changing, and that condition is nothing but circular motion. So friends, I will make it now very clear to you in the next slide that how we can relate the linear part with the circular part. Coming to the point here, if this is the circular path and this is the radius, so as I said you that this is the perpendicular, this is velocity, and this is r. So this is final position. So we all knew about the condition that what is displacement? Displacement is the vector which is joining initial position with the final position headed towards the final position. So definitely I am going to draw one diagram, or you can say that here it is. This yellow line is representing what? It is representing displacement vector. Great. So it is nothing but s. S is the linear displacement. So that way, if I am telling you that what happened, so I can say this is theta. and if it is r is changing, r initially changing to r final, so that way I can say if it will be represented with s, so we can write down what s is equals to r theta. Great. So theta is circular quantity and this is the linear quantity. If s is equals to r theta, so differentiating both the sides with respect to time, we get ds by dt is equals to r d theta by dt, and that way we can write down what v is equals to r omega. Great friends, that way we can also write down a is equals to r alpha. Wow, I mean what, d square s by dt square is equals to r d square theta by dt square. Got my point? So this is a point which you can just keep it in mind, so that the next part will be very clear to all of you. And next part is what? So refer to the previous slide. I said you non-uniform circular motion is having two parts. One is uniformly accelerated and another one is non-uniformly accelerated. So now I am going to cover uniformly accelerated motion. Uniformly accelerated motion. So friends, we all know about rectilinear equations. We have nothing to do, we have just to correlate all the linear equation quantities with circular motion quantities, like as similar to what I am showing you here. Here if I am taking one example, here if I am writing v is equals to u plus at, and then I am writing v square is equals to u square plus 2as, and then I am writing what s is equals to ut plus half at square, and again I am writing what s nth is equals to u plus a by 2 into 2n minus 1. So that way if I will be writing it in circular conditions, so v will become what omega, initial velocity will become what omega naught plus alpha into t. Same way here if I am writing, it will become what omega square is equals to omega naught square plus 2 alpha theta. Same way if I am writing it here, theta will be equals to omega naught t plus half of alpha t square. And here if I am writing it, it will be written as theta n is equals to omega naught plus alpha by 2 into 2n minus 1. Great students, I hope all these points are very clear to all of you, and that way if I am taking you to the next slide, we'll be coming to know about more and more about all these topics by the help of few numericals, and that will be backed up with few of the tricky questions. Now coming to the next slide. So one question if I am taking, and it is direct question which need not to go through all the logics of physics. In fact, a student who is good in mathematics, they can also solve this question. If suppose alpha is given as 5 theta cube plus 2 theta plus 1, then can we find out the value of omega? Can we find out the value of omega? And if we can find out the value of omega, what we need to do? So this is one question, as because it is talking to you about alpha as the function of theta. So we have to apply the formula of alpha to be omega d omega by d theta, friends. So that way we can write down what? Alpha d theta is equals to omega d omega. Great. So we can write down what? 5 theta cube plus 2 theta plus 1 and all get multiplies with d theta is equals to omega d omega, and both sides if I am integrating, I will be getting the value of omega here, and this way this is one kind of question. So student, you need to find out the value of omega here, and if it is starting from rest, if omega naught is considered to be 0, so in that way you need to find out the value of omega, and for all that to know, what we have to do is we have to just find out the value of theta. So here I am taking you to the condition that it is moving from 2 radian to 5 radian. If I am taking you, I am telling you that it is moving from 2 radian to 5 radian, find out the value of omega. So can you find it out? If theta is changing from 2 radian to 5 radian, can you find out the value of omega? I think you can. So this will be the homework for you all. You have to solve it by yourself. If there will be any doubt, just post it in the comment box. I will be coming up with the solution part of this question. Great. So here this is one part, and now coming to the next question. It is little tricky. It is little tricky. If I am telling you, it is little tricky, not much. It is little tricky, and this question will be having two segment. One, I can solve it by subjective part also, and I can solve it in the form of objective as well. I mean, it can be time saving way of solving the question, and at the same time, few of the students who will not be having that much deep concept, they can waste a lot of time in solving this kind of question. Okay, so we are now starting with this question here. What is the question? So coming up with the question, if an object is covering one radian in t is equals to 1 second, starting from, or you can write down here as theta 1 in t is equals to 1 second, starting from rest, and in another t is equals to 1 second, it is covering theta 2 radian. Find out the value of theta 2 is to theta 1. This one is a kind of question which may be asked in JEE mains examination. So students, you need to be very focused while solving this question, and one tricky answer I am going to give you, and subjective you need to solve it by yourself. If not, then I will be coming up with the solution part, and if you are facing any kind of problem, just drop it in the comment box so that I can come up with the solution part of this question in the next coming video. Fine. So now taking you to the Galileo trick here. Wow, Galileo was the great person. I must say, it is Galileo trick. I can apply this Galileo trick to solve this question. Friends, if I am telling you the Galileo trick part, then what I can say you, if it is Galileo trick, so we all know about one sliding part, and here it is some theta angle, and if I am taking each segment of this particular part, and if I am telling this is 1 second, one again 2 second, again 3 second, like this. So what Galileo said, irrespective of this theta, if some object will be here, and if it is, I mean, it is not theta, I have got some regular monotype of telling theta all the time. So here if it is one object like this, and if it is moving from top point to the bottom point, so at each and every second interval, what will happen, it will come up with 1x, 3x, 5x, 7x. This kind of ratio will be maintained throughout. I mean, the same structure will be taken as 90-degree angle. The same concept will be applied. I mean, first second 1x, second 3x, again another second it will be 5x, like this, and it will be getting dropped to the floor. Got my point? So that way, if I am telling you theta 1 is to theta 2, so theta 2 will be 3, I mean 3x, and upon 1x, I mean it will be 3:1 ratio. If I am telling you theta 2 by theta 1 ratio, then it will be 3:1. If I will be at your position, I will be definitely opting for this particular method to solve the question, which is Galileo trick. If suppose you have not understood this trick, you can just drop it in the comment box, so that in the next video I will be coming with some more descriptive part of this Galileo trick. Students, I hope this session is very entertaining for all of you, and I will be coming up with 5 more sessions for this circular motion to be getting concluded, and after conclusion you will find that miracle will happen, and you are going to solve the question which will be up to of advanced level as well. How, when, and where it will be done, that all I am going to make it clear in the next session. So students, hold your breath, stay excited, so that in the next session it will be very entertaining part for you all to know about all those tricky part and all those easier segments, so that all this physics dilemma which is coming through, which is going through in your mind, that it is very tough subject, I will be making it very easier for all of you. I hope you all have understood all the topics and all the points which I have covered it here. Thank you very much to stay with me in this entire session.